Hello everyone, my name is Michelle. Welcome to my channel. If this is the very first time you see my videos, just as you know, most of my channel's videos were recorded in Chinese, but I will record the machine learning algorithm knowledge in both Chinese and English version. We also plan to provide more English version videos in the future. So welcome to my channel again, and let's just get started. So starting from today, we are going to share a new series with you together. This series is mainly to learn machine learning related algorithms with you together. We hope to help you understand the relevant knowledge points and applications in an all-round way. We will choose Python as our programming language when we need to implement the algorithms. And then at each milestone stage, we will share some specific project practice through the project on Kaggle, aiming to help you understand how to choose models under certain scenarios and why different models may have different results. So of course, along with this series of knowledge point videos, we will also share high-frequent related questions mentioned on the internet. So basically, the whole series will contain more and more detailed content, and I hope you will enjoy it. This series of the videos is suitable for all friends. No prerequisite is required. We will try our best to make the content easier to understand. Typically, everyone who is interested in starting learning machine learning algorithms can come and learn together. Okay, so first of all, let's talk about what is machine learning. At this time when the AI or data industry has just become extremely popular, so I believe that even if you have not studied the relevant content in detail, you must have heard some relevant information. But what machine learning does, except for skilled professors or employees in the related fields, may not be able to just really explain it very clearly. When many friends start to learn, they are often scared of by all kinds of heavy books. Like once we open that book, there are all kinds of complicated formulas and overthrows, so which is very confusing for us like at the very beginning. Another part of the friends may just not care which fields they are in now. They may have heard the magic of data science. I always say like data science is one of the sexiest professions in the 21st century, and they are full of expectations for potential career paths in the future. So within this series of videos, we would like to introduce the basic concept of machine learning and let you get familiar with the terms, which could help you to identify if this type of job is suitable for you or if you are really interested in this field. Next, we hope to use a simple example to help everyone understand what machine learning is and what kind of problem machine learning is going to solve. So let's go through a story together. The main character of this story is Billy. So Billy wants to buy a car, and he wanted to use some calculations to see how to raise and buy a car to save money. Like all of us, we want to go to the internet and check a lot of relevant information and advertisements. And then he found a rule, like saying that there is a very obvious relationship between the price of the car and the time, as it decreased by $1,000 per month, but the minimum will not be lower than $10,000. For this case, in our machine learning, is a regression-related case. So that is, we need to predict the price of a specific car based on the known historical data. So within the story, everyone may question that why such a simple calculation still needs a machine. Maybe elementary school student also can predict it. But in fact, in a real environment, it is often much more complicated. For example, we'll not only consider the age of the car, but also the condition of the car itself, such as the relation between the supply and the demand, whether there are additional parts, maintenance cost, and so on. So when we consider so many dimensions of the information comprehensively and try to find our the hidden relationship between the data, it becomes extremely difficult. Therefore, in this complex scenario, we need to borrow machines to help us perform calculations and find the corresponding underlying patterns. And the facts have proved out that, on one hand, most of the time, the problems we have to solve in the real world are very complex and there are not a single influencing factor. On the other hand, Machines can indeed help us to analyze to some extent potential loss and dependent factors that can be directly discovered through the thinking. From here, machine learning was born. To roughly understand the value of the machine learning, we need to understand the three important components of machine learning. First, it is data. So data is basically for all our analysis and model buildings. If there is no diversity data and a sufficient amount of information, it is impossible for us to extract useful information and make predictions. So next question, where does the data come from? There are generally two ways. One is that we can collect data manually, which is relatively time-consuming and cost-intensive. Not very efficient, but the advantage is that there are relatively fewer errors. Another method is to extract the data or to grab the backlogs on the application. So this method is relatively efficient, but the data quality is difficult to guarantee. I can just tell you a fun thing here. So do you remember that every time when we log into some accounts or register some information online, we often ask us to choose some pictures from certain characteristics from the 9 pictures. So in fact, there is also a way for them to convenient to let users help them to label data for free. So you can think about it, like when we first get the image data, the initial data does not have specific classification information, it's only the images. And if they label each image manually, it is very time consuming and inefficient. Then we will help to fill in the information as we choose the pictures under the certain simpletons. We actually directly help them to do the job for labeling the image data. The second component of machine learning is feature. Based on the example we just mentioned, the car's kilometers, interior decoration, brand type, etc. So they are all about the car's features. These are also the factors that machine learning cares most about. Machine learning wants to use this to try to find the hidden logic behind and the potential patterns. Before we start studying the algorithms, I would like to let you know when we learn about machine learning in depth, we will find that choosing the right features is often more important than choosing a fancy model. So regarding the content of this part, I believe that everyone will understand it gradually. So in the last part, it must be the machine learning algorithm itself. We will continue to learn specific content with you in the next few months. In that case, you don't need to be too nervous. But at any time, I hope everyone must notice that there is never the best algorithms, only the most suitable scenarios. So therefore, we are not simply learning the definition of a particular term, but more importantly, learning how to choose and fit the proper algorithms under a certain kind of scenarios. For those who are just starting to learn machine learning, it is often difficult to distinguish a few terms. Therefore, let's first try to understand the relationship between them. So based on the picture on the right side bottom, the relationship of these terms is very straightforward. Artificial intelligence, we call it as AI, is a very big concept and a specific discipline. Machine learning is an important part of AI, but it is not the only part. Neural network is very popular, but it is a branch of machine learning, and deep learning is the specific direction and implementation method of neural networks. Okay, so let's take a look together. In this series of learning, what core important algorithms we will learn. First of all, I hope everyone must remember this picture and see it as a cheat sheet. So this can help you quickly distinguish which algorithms a specific algorithm belongs to, and it will often indicate that what kind of problems can be solved accordingly. We will start with the classic algorithms. You can see that in the classic learning, there are two parts. Supervised learning and unsupervised learning. We will first learn the regression in supervised learning, and then we will learn the classifications. After that, I will explain unsupervised learning in sample methods, neural networks, and the reinforcement learning just one by one. So I want to say learning machine learning is a relatively long process. It may be different from mastering SQL or Tableau skills, but I want to just emphasize a little bit is in many cases, the more difficult it is to master and learn, the more likely it is harder to be replaced. Even for the same level of the job positions, the higher the income can be expected. So if you want to learn and master relevant knowledge, or if you want to find a job in the related field in the future, I want to tell you that the future is currently promising. Okay, let's start with some basic overviews. At present, machine learning is mainly divided into the following 4 directions. When the data is relatively simple and the information of the feature is very clear, then the classic machine learning is always a good choice. If we do not have enough data, but we can interact with data or actions to a certain extent, then we can choose reinforcement learning. If quality is very important, then we will choose ensemble with a high probability. The last one, for more complex data and unclear features, we can use neural network and deep learning when we don't have any ideas, but still that there are some potentials, we think. So classical machine learning. Okay, classical machine learning is the backbone of much of the internet. Have you ever wondering why your bank randomly blocks your card at a gas station, or why you see the suggestions for what to read next? That's these algorithms at work, quietly making the decisions behind the scene. So despite all the advanced algorithms, classical approaches still maintain or remain the fundamental nowadays. So they're like the arithmetic. They use them every day, often without realizing it. So they are very powerful in their simplicity. We have actually seen the corresponding classification just now, and let's review the details a little bit further. So classical machine learning is mainly divided into 2 categories, supervised learning and unsupervised learning. So under supervised learning, there are mainly 2 parts of it, so just classification and regression. Under the unsupervised learning, it is mainly divided into clustering, dimension reduction, and association. So we will share the details with you later one by one. So what are the specific differences between these 2 categories? Supervised learning is like having a teacher provided to the machine and assist the machine in learning. In the dataset, the data will be clearly categorized and labeled, and the machine will use this training data for further learning so as to master how to distinguish the data into specific categories. Unsupervised learning means that there is no specific data division and labeling during the training, and such a teacher is missing. So the machine needs to learn by its own. Obviously, a label training is faster, so it actually, in most of our scenarios, supervised learning is still often used more. You don't need to memorize all the content now, but I hope that whenever we learn a specific algorithm in the future, we can come back and correspond to the overall framework that I talked about today. This is very helpful to help you to build the knowledge structure step by step. And then let's take a look at the specific categories and the corresponding applications one by one. The first one is classification. You can also say from the name that the algorithms of this category is based on the historical data to classify. For example, classify fruits according to the type, classify documents according to the language, classify the music according to the type, and so on. So classification is often used in the areas of spam filtering, language detection, and etc. And also the most common algorithms or the popular ones is naive Bayes, decision tree, logistic regression, KN, SVM, etc. And next is the regression. The algorithm of the regression category is mainly to find a line that fits the data best because it is relatively simple and easy to understand. It will also be the first machine learning algorithms we will learn. So regression including the stock price forecast, demand and sales volume analysis, and etc. The most popular algorithms is linear regression or the polynomial regressions. Another category of the algorithms is clustering, and from here is all about unsupervised learning. This type of the algorithms can help you to find the potential connections by giving the unknown features to classify them. So clustering often used for the market segmentation, merge the close points on map, etc. And the popular algorithms like k-means clustering, mean shift, or DB scan. The next one for the unsupervised learning is called the dimensional reduction. If you haven't started in school or use this very often, it may sound relatively unfamiliar. This type of the algorithms is to abstract the multi-dimension features values into more effective features and reduce the original data dimensions. You may not be familiar with this term, but you must be familiar with the field which is actually using. So it is popularly used for the recommendation system, like the risk management and etc. And you probably heard about the algorithms like the PCA, LDA, and all the other things. The last part for the unsupervised learning is just called the pattern search or association rule learning. And we are using this for the forecast sales discount, analyze goods board together, and etc. Besides supervised learning and unsupervised learning, we will also expand the following type of the algorithm in detail. So the first is the reinforcement learning, which is extremely popular nowadays. Reinforcement learning is often used for the self-driving cars, reboot vacuums, games, automating trading, and enterprise resource management. And there's a lot of popular algorithms like the Q-learning. And the next one is called ensemble method. It's often used for the computer vision, object detection, and etc. You probably heard the algorithms like the random forest and gradient boosting. The last part, but not the least, is just the neural network and the deep learning. It is also the most difficult part for most of the people to understand and master. Neural networks are often used in the areas of replacement of our algorithms we mentioned above, the speech recognition, image processing, and the machine like translation, etc. So the popular architects is like the perceptron, CNN, RNN, and etc. So the above is just what we will explain to you about machine learning and the general framework. I hope that through this series of content, you will not only learn the knowledge points and the mathematical relationship of each algorithms, but also learn how to apply and the specific code in practice. So as I mentioned earlier, like machine learning algorithms is indeed not easy to study as any other like skills in data and AI related field. But from a long-term perspective, learning machine learning will definitely help you to make great progress in the data industry and also may help you to accelerate your career path. So I hope everyone can stick with me and just believe that the future can be expected. We just need to follow along and study together. So at the end, thanks for watching my videos. If you like my videos, please give me a thumb up. If you haven't subscribed my channel, please do subscribe my channel and recommend my channel to your friends. Thank you so much again and see you in my next.